Okay, so today I'm going to teach you 3 different things that we can do. Kind of 4 different things. It's like 3. You could say 4. I might say 3. 3 different things you can do with determinants. The first one you can do with really any size of determinant. But then the last things we talk about after Cramer's rule will be specific to a 3 by 3 determinant. Okay, and I distinctly remember you all saying yesterday, can we have more determinant homework? That was easy. And I had many people say that. Do you remember saying that?
That was easy. I don't remember.
Maybe I didn't hear the word easy, but I heard I liked that homework.
Yeah.
Okay. Okay. So let's talk about what we can do with these determinants, and I'll give you more homework with determinants. Okay? All right, so Cramer's rule is a way to use determinants to solve a system of equations. Okay, remember I told you there was going to be 3 different ways we get to solve systems of equations? Okay, here's our third and final way. Okay. Now, this rule cannot be used every single time because we're going to use a determinant in a fraction. And if that denominator determinant is 0, that's not okay. So if our determinant is 0, we can't use it. So we can't divide by 0. Okay, so I'm going to show you what one of the variables is going to look like. And then we're going to apply the same process for however many variables we're going to have. Okay, so I'm going to show you what the x variable would look like. And then we'll talk about how it would change for y, how it would change for z. If we had 4 variables, how would it change for that 4th variable? Okay, so you're going to create a fraction for each variable. You're going to have a determinant in the numerator, and you're going to have a determinant in the denominator. So I've named them with the letter D, and then the numerator is going to have a subscript that will match whatever variable we're looking for. Okay, so the determinant in the denominator is never going to change. It is always going to be the coefficient matrix. Okay, take all of the coefficients from your variables, x, y, z, and create a matrix that goes in your denominator. Okay, so what's the numerator? The numerator is going to look different depending on the variable that you're finding. Okay? If it's the x, rolling. Okay, so d sub x is the determinant of the coefficient matrix where the x column is replaced by the constants. So I'm just going to go ahead and let you write it down. I understand that you may not understand what that means right at this second, but I'm going to show you what that looks like. If you have it written down, you can refer back to it later. mean by the constant matrix? Okay, the numbers that are on the other side of the equal sign, there's like one of them for each equation. Okay, those would be the constants. So we're going to take the matrix that we had for the coefficients, and if we're solving for x, we're going to replace the x column with those three numbers. If we're solving for y, we're going to replace the y column with those numbers. And if we're solving for z, we would replace the z column. Okay? So if we have a 3-variable system, you have 4 different determinants to find. If you have a 2-variable system, you have 3 different determinants to find. Okay? So we're going to do a 3-variable system because that's where I see the most benefit to Kramer's rule is in a 3-variable system. If we don't have our calculator, we can't do a matrix equation. And some of you aren't really fans of an augmented matrix and row operations, okay? So let's just see what the benefit to using Kramer's rule would be instead. So please write down this system of equations. Okay, so this is what Kramer's rule says. No matter which variable we're finding, for our denominator, we are going to put the determinant of the constant matrix. So our constant matrix would be -1, 2, -3, 2, 0, 1, and 3, -4, 4. Every single denominator would have that. So once you find one variable, you can transfer your denominator to the other ones. Okay? Now, since we're solving for x, we are going to put a determinant in the numerator where the x's get replaced by these numbers right here. And then every other column gets to stay the same. Process that for a moment. Questions about how we set it up? Where any of those numbers came from? Ask me now. Yes?
Is there a reason why you only replace x?
Because we're solving for x.
So if you're solving for y, so you replace those ones?
And we'll do that here soon. Okay? So let's just find what these determinants are. I know you're all itching to find a determinant because you thought they were nice to do. So how about this? Pause 1, 2, 3, and 5. Find me the numerator. Pause 6, 7, and 8. Find me the denominator. What do we get for this numerator determinant? 8? Do we agree with 8? People over here, how about our denominator? So x is 4/5. Okay. Guess what? When we go to find y, what's our denominator? Our denominator is 10. We don't have to find it again. Okay? And when we go to find y, we are going to take the middle column, the y column, and replace it with the constants and keep the x and z column the same. When we go to find z, like you said, our denominator will be 10. But our z column is going to be replaced with those constants. And the xy column will stay the same. Okay, so I am going to give you a couple minutes to see what you can get me for those two determinants.
It's a determinant at the bottom.
Sorry for all the dings. Mr. Griebel's like emailing me panicking about something. All right, what do you get for the y numerator? What did you get for this determinant?
-15.
What did you get for the z determinant?
I got -16.
I reduced it to 8. Oh, I got it.
Trust yourself, man.
I got you. I got jobs.
Okay, if you copy these down, you should get products of 0, 0, -8, and products of 0, 0, 8. So you have negative 8 minus 8. Okay, so those of you, look at your work if you didn't get that. Okay, so since we're solving a system of equations, our coordinate is 4/5, negative 3/5. Whoops. 8/5.
It's positive 8/5. Negative.
So that and that was negative.
Yeah.
Okay. All right.
All that.
Can you imagine trying to do this in row echelon form? And getting all these fractions? Okay. So Kramer's rule, while yes, could be somewhat tedious because you have 4 determinants to find.
That's okay.
As long as you're comfortable finding determinants, it gives you an alternative to the other ways that we know. Okay, I will tell you this. On your test, you will always get a choice, but it won't be of all 3. I'll say use one of these 2 methods. Does that make sense?
Yes.
Okay. If you had a 2-variable system, you would have 2 by 2 determinants to find. And that would be really quick, wouldn't it? Okay, those are quick to find. Questions about Kramer's rule? We have 3 ways to solve a system with a matrix. How many of you think you might like Kramer's the best out of the 3?
What was the second one?
The second one was like the equation and you find the inverse to multiply over. No.
This one's second.
Okay. Okay, share with your neighbor while I go to the next slide. Which of the 3 methods do you like best?
This one. This one's the easiest.
Max? Yes. I was processing. Yes. So all the ones I will give you will be. All right. We can find the area of a triangle using a matrix. Okay? If we know the coordinates of a triangle, okay? Now, you all are thinking, Mrs. Homan, an area of a triangle is 1/2 base times height. I know. However, do we always know the height of a triangle?
In our word problem.
If I gave you 3 coordinates, what's the height of that triangle? It's this right here. This is the base, that's the height. How are you gonna find the height? With the, but you don't know what this is.
Find the distance between those 2 points divided by whatever.
You know coordinates.
Sine, cosine.
It would take a lot of geometry to find the area of a triangle if you only know 3 coordinates and you know it's not a right triangle. Okay? Or we have this application right here. I don't know if you guys are completely convinced how much work that would be. So if you have coordinates, you'd have to do the distance formula to figure out all the sides. And then you have to figure out where your altitude would be to draw it, and you would have to find that distance, and how far away is it from the other one. And then you can use Pythagorean theorem, but still, a lot of math involved. Okay. As you're writing this in, please note that the coordinates are together in a row, but it really doesn't matter which order the coordinates are in, as long as the x and the y from one coordinate are together in a row. Okay? Also notice there's a plus or minus 1/2 on the outside. Why would I have a plus or minus 1/2? Do I have 2 answers? Somebody said something. What about the plus or minus? What could be either? You're on the right track, Riley. You're on the right track. Can we have negative area?
No.
No. Could we have a negative determinant?
Yeah.
Yes. Your determinant could be positive or negative. So depending on whether your determinant is positive or negative is going to affect which one of the plus or minus 1/2 we use. We want what kind of area?
Positive.
Positive. I should really not have those in my hand. Are you ready for an example?
Yeah.
Okay, are you done writing this down?
Yes.
Here are the 3 coordinates of a triangle that we're going to find the area of. What?
So 1/2 always stays the same.
Yes, the 1/2 always stays the same.
What does the determinant have?
What?
What does the determinant have?
It helps us find our, well, we could go through like a big long geometry proof of why this works.
Let's not do proofs.
Or you could just believe me that it works.
Guy said, I don't care. Let me go.
Okay, so this is what you're going to do. Our area is plus or minus 1/2 times the determinant of x, y, 1. X, y, 1. X, y, 1. So you always have this third column of ones, and then your rows are determined by your coordinates. So here's the determinant that we need to find, right? We need to calculate this determinant. So help me out. We have 2 plus, okay, minus the quantity, plus. So do you agree that our determinant is 8 minus 11?
Yes.
And what is 8 minus 11? -3. So if we want to calculate area, which 1/2 should we choose? So we have a positive area. An area we always label in square units.
That's the area.
Yep.
Awesome.
Okay, I have a question too.
Yeah.
What are the matrices used like anywhere, like where you work? Sometimes like what do
Of course.
wondering like where would you use?
Like an entire
Let's go.
class.
You're a math teacher. You need to know
Coding,
Okay, math.
and computers can be one application.
You use it like the Air Force?
Yeah. Something like do you guys remember doing your linear programming stuff?
Yeah.
Okay, so in a class in college, I did that with like multiple equations, multiple variables, and so we used like matrices to organize it and solve the answer. Okay. All right. Believe it or not, yeah, there is.
Yeah.
What would happen if I did this determinant and it would equal 0?
Uh-oh. You'd have to give up on the side
There's
triangles.
no time.
Okay, it's not a triangle, so my 3 points.
Aren't the triangle.
Are in the line.
Aren't-
Imagine there was. Max, did you just guess that? Or did you actually like? It's all in my head. Oh, yeah, okay. That was good.
If we have 3 points that lie on the same line, this determinant that we use for area would equal 0. So if I ask you to determine if 3 points are collinear, yes, you could find the slope between the points 3 different times to see, or you could find a determinant. Emma, do you have a question? Okay.
Pretty smart.
Some of you guys like to have options, okay? Like if I say, like my husband and I are going to go to dinner tonight, right? We always like to have like 5 choices and then we like narrow it down from there, right? Not just like this is where we're going to go, okay? In math, sometimes it's nice to have options. If you really like doing algebra, then that's fine. But I will tell you on the matrix test, I will expect you to use this to show that points are collinear.
So when it calculated and non-calculated part, like
Yes, yes. Okay, so if I said, are these points collinear? On the matrix test on, for you guys, will be Wednesday. We're not going to do it during group picture day Tuesday. That would be a disaster.
Yeah, I like it a lot. My Jones is like 2 hours yelling in face. Yeah, it doesn't matter. 6 and 7 hours.
If I asked you on the matrix test on Wednesday, are these points collinear? I would expect to see you put them in a matrix with that column of ones, similar to how you would set up the area of a triangle. And find the determinant. What do we get? What does that tell us? These are not collinear. We want that determinant to equal 0, okay? We could find the area of this triangle to be a positive 3 because we have that value. If that value of the determinant was 0, we would have 3 coordinates in a line. Yes, they would be collinear. Okay? So, if we know that 3 coordinates are collinear, if this matrix is 0, then we can actually use this matrix to write the equation of a line. Talk me through the process. I give you 2 points. How do you write the equation of a line? What do you find first? You find slope, and then you plug your slope into a line. Y equals mx plus b. You take a coordinate, you figure out what b is, and then you have y equals mx plus b. Right? Okay. Another option that we have, since we know that this matrix would be 0 if they were collinear, we could plug in 2 coordinates with a generic coordinate x, y. And if these 3 coordinates lie on a line, the determinant should be 0. So this will actually give us the equation of a line without having to calculate slope. This is the last thing we're doing. We have one more example and that's it. Oh, that's strong. Your hands are kind of that. Okay, you ready for our last example of chapter 8?
Yeah.
We're going to write the equation. How's that? There. Find the equation of a line passing through 2, 4 and -1, 3. Yes, I know that we can do this using algebra, but what's neat is we can also do it using a determinant. Okay? If 3 points are collinear, the determinant that we find should equal 0. That determinant has a third column of 1s, and it has our 3 coordinates. The first coordinate, we're just going to put a generic x, y, and then we're going to put in 2, 4, and -1, 3. Okay. I'm going to move this 0 over. Okay, and we're going to do this the same way we would do any other 3x3 determinant. Okay, we're just going to have some x's and y's in our products. So we have 4x minus y plus 6 in our first sum. Then we're going to subtract our up diagonals. -4 plus 3x plus 2y, and we know that that should equal 0. Okay. Now it's a matter of combining like terms. How many x's do we have? How many? 1x. Our y's? -3y. And then we have 6 minus -4. So what I would probably write is x minus 3y equals -10. That's the equation of a line in standard form instead of slope-intercept form. That's fine. You can leave it like this. You don't have to solve for y. This is still the equation of a line. So your homework tonight, you have these 4 skills to practice. Okay. You will have some Kramer's rule 2x2s, some Kramer's rule with 3x3, and then triangles and collinear points to figure out. Okay. We have 6 minutes left in class, so I'm going to stop this